Hey guys, another version of video here. For today's lesson, you can see we're going to be working on subtracting mixed numbers. So just like in the previous video when we were subtracting fractions, this time we're going to get into mixed numbers. And just a quick recap here, if you look on the left side of my equation, 1 1/4, that is known as a mixed number because it's a whole number mixed with a fraction. 1, the whole number, right, that represents a whole, whatever the whole may be, and 1/4 of another whole. So it's a mixed number called because it's a whole number mixed with a fraction. So in this, I'm going to show you a couple strategies for how to solve these problems. So let's get into it. And we'll start with that same problem, 1 1/4 minus 3/4 equals r. And again, just like yesterday, what you might realize is we're dealing with the same denominator. Right? Every one of these problems we're going to see is going to have the same denominator. The problem with this subtraction problem in front of you is I'm trying to take 3/4 away from 1/4. And based on previous knowledge of subtraction, you cannot take a bigger number away from a smaller number, right? If you only have 1/4 to give away, I can't possibly take 3/4 away from that. So we need to fix that to make sure that the fraction on the left side over here is actually bigger than the fraction on the right side, so I can take a value away from it. And what we're going to do is it's all based on that whole number of 1, right? We have one whole, and in this case, one whole would be the same as having 4/4, right? We're dealing with fourths, that's our denominator. So one whole would be the same as 4/4. Well, if I write one whole as 4/4 instead of as one whole, I could take those 4/4, which would be the one whole, plus the 1/4 I had originally in 1 1/4, and that would give me a total of 5/4. Now if I write the equation as 5/4 minus 3/4, I have the same denominator, and now I can just do a straight subtraction. 5 minus 3, 2/4, right? R would equal 2/4. So what you're going to have to look at carefully is, if you have a mixed number as 1 1/4, can you trade the one whole in for 4/4 or 3/3, whatever denominator you're dealing with, and make an improper fraction, like 5/4 down here, right? That's improper. We have a bigger numerator than a denominator, but that allows us to take 3/4 away from 5/4. Let's look at another one. And this time we'll go with 2 3/5 minus 4/5. Now, take note right away that we have the same denominator, fifths on both sides. One side of my equation on the left side over here, I do have a mixed number, 2 3/5, and I'm trying to take 4/5 away from it. Well, just like last time, 4/5 is bigger than 3/5, so I can't take 4/5 away from 3/5. So what I need to do is take one of these wholes, right? In this case, I have 2 wholes. Last time I had 1. I can take one of those wholes away, so I'm still going to have one whole, but the whole I'm taking away, instead of one whole, right, this time we're talking about fifths, so the whole I'm taking away is going to be represented as 5/5. So I would really have 1 5/5, which is another way of writing 2 whole, plus the 3/5 that I had in my original fraction, which would give me 1 8/5. Now I know that looks kind of like a strange fraction, and it is, because it's a mixed number and it's improper. But we're only writing it like that so that we could subtract 4/5 from it, right? Same denominator, fifths and fifths. Now I could just do a straight subtraction. 1 8/5 minus 4/5 is still going to leave me with one whole and 4/5 left over. It's that idea of trading in some of these wholes. In this case, I had 2 wholes. Trading some of those in and writing it as 5/5, which I did right here, instead of keeping it as 2 3/5. Right? Let's look at another one. And this time we'll go with 3 1/6 minus 1 4/6. Right? So we're dealing same denominator again. As I said, that's what they're all going to be. But you'll notice in this one I have 2 mixed numbers. Right? 3 1/6 minus 1 4/6. Again, though, the fraction I have on the right side of my equation over here, 1 4/6, the 4/6 is too big to take away from 1/6. So I need to fix this. I'm dealing with 3 holes. I'm going to take one of those away, so I only have 2 holes left. And we're dealing with sixths. So instead of a hole, writing 1 hole, I'm going to realize that 1 hole would be the same as 6/6. Well, I pulled one of my holes away, right? Started with 3. Now I only have 2. That means I can add 6/6 to the 1/6 I had and end up with 2 and 7/6 minus 1 and 4/6 equals straight subtraction. 2 minus 1 is 1. 7 minus 4, 1 and 3/6. Now, some of you, might be looking at that and going, hey, that's the same as 1 and 1/2. That would be correct. Either answer would be acceptable. Okay? Look at one more. I'm going to give you a chance. This one you can try to work out yourself. And we'll go with 4 and 1/4 minus 1 and 3/4 equals x. Same denominator. Again, 3/4 on this side is bigger than the 1/4 over here, so you need to fix the problem. Take one of those 4 holes away, rewrite it as 4/4. You can add that amount to the 1/4 you currently have. See if you can solve it. Go ahead and pause the video. Be back with you in a second. I'll show you the answer. Okay, you should have had a chance to pause the video. If I take 1 hole away, I'm going to have 3 holes left. Instead of that 1 hole, I'm going to write it as 4/4. Right? We know that 1 hole in this case would be the same as 4 out of 4. That would be my whole thing. I'm going to add 4/4 to the 1/4 I already have and have 3 and 5/4 minus 1 and 3/4 equals 3 minus 1 is 2. 5 minus 3 is 2. 2 and 2/4. For an extra challenge, how would you rewrite that fraction as another equivalent? That's right. 2 and 1/2. Check out the video again if you need to. You can also look up other videos if it might help you. Some might have a visual display. When you come see me, we're going to work with some fraction circles, draw some fraction bars, and see if we can figure out how to master this skill of subtracting mixed numbers. I'll see you guys in a bit.